InCare is an IoT system that aims at providing services for intensive care patients monitoring. The expected results consist on improving the monitoring of patients, letting the medical staff request data about registered parameters, as well as receive alarms if the parameters become critical. The main features InCare offers are measurement of environmental conditions by a sensor that provides two resources, temperature and humidity. These measurements take place on Raspberry Pi, where the sensor is physically connected. These resources are available via MQTT. Acquisition of vital parameter, pressure and oxygen saturation. These resources are provided by a cloud that we created to simulate the iHealth cloud. An iHealth adapter is used to retrieve data from this cloud and lets data available via MQTT. Remote acquisition of analog ECG that is acquired on Arduino Leonardo. Arduino sends this data via MQTT. A signal processor acquires all the data from each patient and processing them in order to detect the presence of a critical condition. If this condition is verified, it will send an MQTT alert. End users applications for monitoring, ThinkSpeak, Freeboard and Telegram. These applications will be shown in detail later. Catalog is the main actor in the system, as it communicates with all the microservices via REST. The only modification we made is that the catalog communicates via MQTT with Arduino. Catalog will be the first we introduce to understand how the whole system is organized. This is an example of the catalog used in our system. The catalog is a JSON and the main keys are patients, users, broker and database. Patients is a list of all the patients, in which every element of the list is a single patient. Every patient has a patient ID, a read API key, a channel ID and a write API key. These last three values are used to store and retrieve data in ThinkSpeak. Every patient has also a list of devices connected to him. In this case, the devices are Arduino and Raspberry. Both Arduino and Raspberry have a timestamp, a device ID, and the resources related to them. Arduino has only one resource. Each resource has the MQTT topic, the name of the resource, the field in ThinkSpeak, the units of the resource, and the URL related to the resource. Raspberry instead has 5 resources that are temperature, humidity, pressure, oxygen saturation and heart frequency. Users is the list of the doctors connected to the system. We can see that each user has a chat ID and a patient ID. We see that patient ID is an empty array. We will see later, when we will explain how Telegram works, that each user will have a chat ID and a list of patients related to him. Broker contains the information about the broker. It has an IP address and a port where all the devices that communicate to the broker via MQTT will connect. Database contains the URL of a database where are stored the ECG traces and the picture of the ECG traces. First of all, let's see how to add or delete a patient from the catalog. We connected to Raspberry via SSH and now we run the script. Now we run the web service to add or delete patient. This is the interface to add or delete a patient. If I want to add a patient, I have to complete all the fields. In fact, if not all the fields are complete, a pop-up say that I have to complete them. Now I submit. Now, if we go to the web server, we can see that the patient has been added and there are all the fields, patient ID, start, read key API and so on. Now we can go to the catalog to see if the patient has been added. If we go to the bottom, we can see that there is a new patient, QQQQ, with all the fields. Now we will see how to delete the patient we added. So, if we want to delete the patient, we only have to insert the patient ID. Now we will check if the patient has been removed. We have patient removed, and if we go to the catalog, we can see that we don't have QQQ anymore. ThinkSpeak adapter communicates to the catalog through REST. It makes a GET request to the catalog to receive the list of all patients, and it creates an MQTT client for each patient that subscribe to the topics related to the resources of each patient. Every 2 hours, ThinkSpeak adapter makes a new request to the catalog to check if any new patient has been added or removed. Now we will run the ThinkSpeak adapter. As we can see, it subscribes for every patient. We have 3 patients to the 4 resources. We have temperature, humidity, pressure and oxygen. iHealth Cloud is a simulator of the real iHealth Cloud. It returns JSON NML of pressure and oxygen saturation of the patient that have been requested.
Now we will see how the publisher iHealth works. At the beginning he will ask to the catalog all the patients in their list, and for each patient he will run a client MQTT publisher. For each client, this script will ask to the cloud information about the 2 resources of pressure and oxygen. The requests are done each 50 seconds. As we can see, has just been published a SNML for pressure and oxygen related to the first patient, a SNML for pressure and oxygen related for the second patient, and as well for the third patient. In the iHealth Cloud we can see how has been done 6 requests, and we can see here in the Python ThinkSpeak adapter how we received the requests.
Now only iHealth Publisher is running, so ThinkSpeak adapter will not receive information about resources because it needs all the 4 resources. So now we will run the publisher of the resources from the sensor to see how ThinkSpeak adapter will receive these resources.
Now we will see how temperature resource and humidity resource are published. We have to run the script on Raspberry, and we will pass through parameter the name of the patients about that resource. The client publisher is running, and each 50 seconds both the resources will be published. As we can see, has been published 2 JSON NML related to this patient for both the resources, and now these resources has been received by the ThinkSpeak adapter.
Now that we have all the resources, ThinkSpeak adapter can receive them and the resources are related to the fields of the ThinkSpeak platform. Each time that all the resources are present, they are sent to the ThinkSpeak platform. So, for patient 1, for example, we have a chart for temperature, humidity, diastolic pressure and systolic pressure, oxygen, and then a chart that makes a comparison between diastolic and systolic pressure. For example, field 1 is 25, field 2 64, field 3 75. Let's see on ThinkSpeak platform. The last value is 25 for the first field, 64 for the second field, and 75 for the third field.
Now we will see how the HEG subscriber works. As we will see, data from Arduino will send directly to Raspberry, where will be stored a HEG trace. This HEG trace can be retrieved through a database which URL is stored in the catalog. Now we will run the HEG subscriber. He also will request from the catalog the list of all the patients. He will run also a client subscriber for each patient. In fact, as we can see, for each patient there is a subscription to this topic. Like all the elements in the system that communicate to the catalog to retrieve the list of all the patients, also the HEG subscriber every 2 hours will restart the client, checking if the patient list has been modified. Now we will see how the recording of HEG happens. Each time the button is pressed, a recording starts. When the light is red, the recording starts, and we will see each package who arrives to the subscriber. When the registrations is longer than 5 seconds, on Raspberry will be saved a picture of the trace. As we can see, each time a recording is saved, on Raspberry is saved a picture. It also sends a message under the topic frequency related to the specific patients, in which is reported the actual frequency, in this case 84. This message is useful for the alarm sender, who will send a message to Telegram. As we can see, why the ThinkSpeak adapter is sending everything to ThinkSpeak, we can run Freeboard dashboard. In fact, if we go here and we run the Freeboard dashboard, we can see all the panes related to the resources of this specific patient. We can see in fact that if we try to have the information of a patient who does not exist, Freeboard will return an error. Here we can see that there are 3 data sources: ThinkSpeak, HEG and pressure. ThinkSpeak is useful to retrieve information about temperature, humidity, oxygen, and at the same time these 2 charts, which are directly taken from ThinkSpeak. Instead, here we have the first chart with blood pressure and another chart that now we are not seeing yet. Now we will see what Freeboard dashboard returns when you look for another patient. This patient is present in the catalog, but we have not created his own ThinkSpeak channel. At the same time, there is no Arduino sending ECG with a topic related to this patient. For this reason, you will not find nothing when Freeboard asks for resources. In this chart we can see the last measurement of diastolic and systolic pressure. These measurements are taken from ThinkSpeak but are plotted using a iCharts library. Instead, now we will see how, if we run the database on Raspberry where all the picture and all the trace ECG trace are saved, we will see something. Now, if we run the database and we refresh the page, we can see here the last ECG trace. If the recording of the ECG trace is happening in this time, we will see each 5 seconds the new ECG trace. At the same time, we can see that each 5 seconds, because every 5 seconds the ECG trace is uploaded, the database receive a request. This database is also used to retrieve the image related to the ECG trace. Here we have a new recording which has also a better quality. To conclude about Freeboard, we can say that everything is scalable because after adding a ThinkSpeak channel for the new patient, inserting a new patient on the HTML page and adding the devices for that specific patient that will automatically subscribe to the catalog, Freeboard will be able automatically to access all resources.
We can see that before the user list is empty.
From the terminal we can run the bot and now we can use the application. The command start runs the bot and automatically the doctor is added in the user list of the catalog, if not already present. From the InCare bot it is possible to add patients to the user list in the catalog. We press the command insert that allows this feature and we type the patient ID, for now Polito. Pressing the command list, we can retrieve the complete list of the doctor's patients.
As we can see, now the new user is present in the catalog and also its patient Polito.
The command data allows to retrieve patient's information and vital parameters from ThinkSpeak. First, it shows the list of patients and the doctor can retrieve the data of each one of them. Then it shows a list of data that we can select through buttons. Once we press one of these buttons, for example oxygen, the Telegram bot retrieves the API key for the patient channel on ThinkSpeak from the catalog.
As we can see, the catalog has received the request for the API key and the channel of ThinkSpeak.
Telegram returns the last measure recorded from ThinkSpeak of the oxygen, that is 96. Now we can check if this is really the last value from ThinkSpeak, and it is. It is also possible to retrieve the last ECG record of the patient. As always, we select data, the patient, and then ECG, and the Telegram returns the image. The image is this one, and as we can see, this is all noisy due to problems for the measurement, but it is the last ECG record.
Here, the image database receives the request from the Telegram and sends back the image.
The last two commands are alarm on and alarm off. By pressing alarm on, it gives the possibility of receiving alarm, while by pressing alarm off, this function gets suspended. The alarm sender is the service that receives the data from all the sensors, it confronts the values with some given threshold, and if necessary, it publishes an alarm message. When it runs, it makes a request to retrieve the patient list from the catalog. For every patient, it subscribes to all the sensor topics except for the resources ECG, temperature and humidity. This is because from the ECG record it is not possible to automatically use useful information, while environmental information like temperature and humidity are not fundamental to monitor. The threshold adapter is a functionality useful for those patients having a chronic condition. When the client receives a series of values that are just below the threshold, the adapter lowers the threshold itself so that after a few messages, the program adapts itself to these values. This way, no longer sends messages. The signal processor is a functionality that, depending on the values of pressure, oxygen and cardiac frequency, it can recognize possible arrhythmias of the monitored patient. In particular, it can recognize right heart failure, left heart failure. Left heart failure can be recognized checking the last 4 minutes of recordings. If at least 60% of the recordings are all below the threshold, then there's a suspect left heart failure. Right heart failure can be recognized when, in the same interval of time and in the same proportion, the pressure is still normal while oxygen and cardiac frequency are low.
In all the tests we made till now, devices did not register to the catalog, and the catalog did not delete the devices with a timestamp longer than 2 seconds. If we would have run the scripts that refreshed the devices, the non-existing devices would have been deleted, so we would not be able to demonstrate that the whole system can work with more than one patient. Now we will run the script where the catalog refreshed the device patient and receive the subscription from the only 2 devices we have for this patient. Now we will see that in the catalog we have 3 patients, each of these patients with 2 devices related. If we run the trading, we can see that REST catalog is running, but at the same time he is receiving for now only the subscription of Raspberry, and we can see here also that the timestamp of Raspberry is uploading. At the same time, if we go to check now the catalog, we can see that only for the first patient there is the Raspberry. There is no more the Arduino because we have not plugged it yet, and the other 2 patients have the list of devices empty. Now we will connect also Arduino, and we will see that on the trading he will receive also message from Arduino. Here is really fast, but as we can see also Arduino timestamp is uploaded. Now if we go again to the catalog, we can see that the first patient has also now Arduino. This device before was not present, but the second and the third patient have the list of devices still empty.